If you're preparing for AQA GCSE Chemistry Paper 2 and feeling unsure about what might appear in the exam, we've got you. Our 2025 predicted papers focus on the topics most likely to come up based on patterns from past exams and examiner reports. To make our predictions, we've thoroughly analysed previous papers, question styles and trends. While we can't guarantee exactly what will appear in the exam, this approach helps you focus your revision on the areas that matter. Each predicted paper comes with full exam style questions set to practice under timed conditions, along with mark schemes so you can self-assess and refine your technique. New for 2025 as well, we've also included free video walkthroughs led by experienced teachers and examiners. These videos break down how to interpret questions, how to structure answers clearly and logically, and then how to avoid common mistakes that often cost students valuable marks. Now, we really think that using predicted papers is one of the most effective ways to prepare. You'll become familiar with the exam format, identify any gaps in your knowledge, and learn to approach questions in a way that matches examiner expectations. Most importantly, regular practice with realistic questions helps build your confidence, helping to reduce stress and boost performance on the day of the exam. If you need more support, we also offer chemistry masterclasses. These include live revision sessions that walk through challenging topics step by step, workshops that focus on exam technique, and night before exam prep sessions to help you feel as confident as possible walking into the exam room. And don't forget to take care of yourself. Revision is important, but so is your well-being. Make sure to take regular breaks, stay hydrated, and get enough sleep because balance is really important. Okay, so always make sure to use the timestamps as we're going to look at separate higher, combined higher, then separate foundation, and then combined foundation too. So first up, we have our predicted topics for AQA higher separate science. So one of the key areas likely to come up is the Earth's atmosphere. You should know that it is made up of approximately 78% nitrogen, 21% oxygen, and around 1% of other gases, including carbon dioxide, noble gases, and water vapour. The evolution of the atmosphere began with volcanic activity, which released gases into the early environment. Oceans then formed and dissolved some of the carbon dioxide. Over time, photosynthesis by algae and plants increased oxygen levels while carbon became locked into rocks, fossil fuels, and the oceans. Standing combustion and pollutants is also important. In complete combustion, a hydrocarbon reacts fully with oxygen to produce carbon dioxide and water. Incomplete combustion happens when oxygen is limited, producing carbon monoxide, water, and sometimes soot, carbon particles. Burning fuels also release pollutants like sulfur dioxide and nitrogen oxides, which contribute to acid rain. Carbon monoxide is another, which is a toxic gas. Then you've got carbon dioxide, which contributes to global warming, and particulates cause global dimming and respiratory problems. When it comes to Earth's natural resources, you should be able to distinguish between finite resources like coal, oil, and metal ores, and renewable resources like solar power and wood. Sustainable development is about using these resources responsibly so they are not depleted for future generations. This includes efforts like recycling metals and plastics or using alternative materials such as bio-based plastics. Rates of reaction is another key topic. The rate of a chemical reaction is affected by temperature, concentration, surface area, and the use of catalysts. According to collision theory, particles must collide with enough energy, known as the activation energy, for a reaction to occur. Increasing any of these factors makes collisions more frequent or more energetic, thus speeding up the reaction. Next, make sure to revise the tests for gases as these often come up in exams. To test for hydrogen, hold a lit splint near the gas. If hydrogen is present, you'll hear a distinctive squeaky pop. For oxygen, use a glowing splint, not lit. If oxygen is present, the splint will relight. To test for carbon dioxide, bubble the gas through lime water. If carbon dioxide is present, the lime water will turn cloudy. And finally here, for chlorine, hold a piece of damp blue litmus paper in the gas. If chlorine is present, it will bleach the paper white. Okay, next we have Le Chatelier's principle, which we think may also be tested. This principle states that if a system in equilibrium is disturbed, the position of equilibrium will shift in the direction to oppose the change. For example, increasing temperature shifts the position of equilibrium towards the endothermic reaction. Increasing pressure will shift the position equilibrium in the direction of the side with fewer gas molecules. Another area to revise is fractional distillation in crude oil. Crude oil is a mixture of hydrocarbons, mostly alkanes. When heated, the vapours rise through a distillation column and condense at different levels based on their boiling points. Smaller molecules have lower boiling points and are more flammable, while larger molecules have higher boiling points and are more viscous. Organic chemistry is another important area. You'll need to know the difference between alkanes and alkenes. Alkanes are saturated hydrocarbons with single bonds, while alkenes are unsaturated and contain at least one double bond. Combustion of hydrocarbons produces carbon dioxide and water. Cracking is a process used to break long chain hydrocarbons into shorter, more useful ones. Then we have life cycle assessments, or LCAs, which help us to compare the environmental impact of different products. The stages include extracting raw materials, manufacturing and transporting the product, using it, and finally disposing of it. LCAs evaluate the waste, pollution, and energy involved in each of these stages. Okay, next, understanding water treatment is also important. Potable water is water that is safe to drink. It's typically treated through filtration, which removes solids, and sterilisation, which kills microbes using chlorine, ozone, or UV light. In areas with limited freshwater supplies, desalination is used. This process involves distillation or reverse osmosis to remove salt from seawater. You may also be asked about the production of ethanol. Ethanol can be made in two ways. Fermentation of glucose using yeast, which is done under anaerobic conditions at around 30 to 40 degrees C, or hydration of ethene using steam and a catalyst under high pressure. Fermentation is renewable but slower, whereas hydration is faster but relies on crude oil. Another topic to be aware of is polymers. Addition polymers are made from alkenes by opening their double bonds to form long chains, such as polyethylene. Condensation polymers form when two different monomers react and produce a small molecule like water. These are used to make materials like nylon and polyesters. I'm nearly there, promise. You'll need to be familiar with how to test for ions. Flame tests can identify metal ions based on the colour of the flame. Lithium gives a red flame, sodium gives yellow, potassium, lilac, calcium, orange-red, and copper, green. For negative ions, carbonate ions produce carbon dioxide bubbles when acid is added. Sulfates form a white precipitate with barium chloride and hydrochloric acid. Halide ions react with silver nitrate and nitric acid to form different coloured precipitates. White for chloride, cream for bromide, and yellow for iodide. Finally, last of all, revise fertilisers. They contain essential elements for plant growth: nitrogen, phosphorus, and potassium. Fertilisers are made by reacting ammonia with acids to form salts. For example, ammonia and nitric acid react to produce ammonium nitrate, a commonly used fertiliser. Okay, those are all of our separate higher predictions for chemistry paper 2. Let's now move on to combined higher. So, as always, our predictions for 2025 are based on patterns from previous year's exams. While this guide highlights the topics most likely to come up, it's important to revise the full syllabus to be completely prepared. Now, anyway, let's start with Earth's atmosphere. The current atmosphere is made up of approximately 78% nitrogen, 21% oxygen, and 1% of other gases, including carbon dioxide, noble gases, and water vapour. The Earth's atmosphere has changed significantly over time. Initially, volcanic activity released gases, creating an atmosphere rich in carbon dioxide with very little oxygen. As oceans formed, some of the carbon dioxide dissolved into them. Later, algae and plants began to photosynthesize, increasing oxygen levels. Carbon gradually became locked away in rocks, fossil fuels, and the oceans. Here, you also need to understand the greenhouse effect and its link to climate change. Next is combustion and pollution. In complete combustion, a hydrocarbon reacts fully with oxygen to produce carbon dioxide and water. In complete combustion, there isn't enough oxygen, so carbon monoxide and soot, or carbon particles, are produced instead. These pollutants have serious effects. Carbon dioxide contributes to global warming. Carbon monoxide is a toxic gas that prevents oxygen from binding in the blood. Sulfur dioxide and nitrogen oxides cause acid rain, and particulates lead to respiratory issues. Now, moving on to Earth's natural resources, you should be able to distinguish between finite resources like coal, oil, and metal ores, which will eventually run out, and renewable resources like wind, solar, and hydroelectric power, which will not run out. Sustainable development means using these resources in a way that meets our needs without compromising those of future generations. We can reduce our use of finite resources by recycling metals and plastics and using alternatives like biodegradable plastics. In rates of reaction, several factors affect how quickly a chemical reaction takes place. Increasing temperature gives particles more energy, leading to more frequent successful collisions. A higher concentration of reactants means more particles in a given volume, again increasing the chance of successful collisions. Breaking solids into smaller pieces increases surface area, which also speeds up reactions by exposing more reactant particles. Catalysts work by lowering the activation energy, making reactions faster. Next, make sure you revise the tests for gases, as these often come up in exams too. To test for hydrogen, hold a lit splint near the gas. If hydrogen is present, you'll hear a distinctive squeaky pop. For oxygen, use a glowing splint. If oxygen is present, the splint will relight. To test for carbon dioxide, bubble the gas through lime water. If carbon dioxide is present, the lime water will turn cloudy. And finally here for chlorine, hold a piece of damp blue litmus paper in the gas. If chlorine is present, it will bleach the paper white. Now next we have Le Chatelier's principle, so make sure to brush up on this. It states that if a system at equilibrium is disturbed, it will shift to oppose the change. For example, increasing the temperature will shift the equilibrium in the direction of the endothermic reaction. Increasing the pressure shifts it toward the side with fewer gas molecules, while increasing the concentration of reactants causes more product to form. In fractional distillation and crude oil, it's important to remember that crude oil is a mixture of hydrocarbons, mainly alkanes. When crude oil is heated, the different hydrocarbons evaporate and rise through a distillation column. As they cool at different heights, they condense into separate fractions. Small hydrocarbon molecules have low boiling points and are more flammable. Large molecules have high boiling points and are thicker and more viscous. We then have organic chemistry. Here you'll need to recognise the difference between alkanes and alkenes. Alkanes have single bonds and are saturated hydrocarbons. Alkenes contain a carbon-carbon double bond and are unsaturated. Cracking is a process used to break large hydrocarbons into smaller, more useful ones, producing both alkanes and alkenes. Okay, next we suggest you revise the life cycle assessments, or LCAs, which help us compare the environmental impact of products by looking at every stage of their existence, from raw material extraction to manufacturing, usage, and final disposal. LCAs consider factors like energy consumption, pollution, and waste produced at each stage. Now, finally, water is also an important topic. Potable water, which is safe to drink, is treated through filtration to remove solids and sterilisation to kill microbes, often using chlorine, ozone, or UV light. In regions with limited access to fresh water, desalination is used to remove salt from seawater using either distillation or reverse osmosis. The stages of water treatment include screening, which removes large debris, sedimentation, where sludge settles out, filtration, which removes small particles, and chlorination, which kills harmful bacteria. Okay, those are our combined higher topics. We really hope they help as a useful starting point for your revision. Let's now move on to separate foundation. While these are the areas we've predicted to appear based on past papers, remember to revise the full syllabus to be fully prepared for your exam. Let's begin with the Earth's atmosphere. The air around us is made up of around 78% nitrogen, 21% oxygen, and 1% other gases, such as carbon dioxide, water vapour, and noble gases. In the past, volcanoes released gases into the early atmosphere, including large amounts of carbon dioxide. As the Earth cooled, oceans formed, and much of the carbon dioxide dissolved into them. Later, simple plants and algae developed and began to carry out photosynthesis, which increased the amount of oxygen in the atmosphere. We also need to understand the greenhouse effect. Moving on to combustion, we're talking about burning fuels. In complete combustion, fuels burn in plenty of oxygen to produce carbon dioxide and water. This type of combustion is clean and efficient. In incomplete combustion, there isn't enough oxygen. So harmful products like carbon monoxide and soot, which is tiny carbon particles, are made alongside water. Carbon monoxide is dangerous because it's a poisonous gas that can stop oxygen from getting around the body, and particulates contribute to air pollution and breathing problems. Burning fuels also releases pollutants such as sulfur dioxide and nitrogen oxides, which cause acid rain, and carbon dioxide, which adds to the greenhouse effect. Next, let's talk about the Earth's natural resources. These include materials we get from the Earth, the sea, or the atmosphere. Some are finite, like coal, oil, and metal ores, they will eventually run out. Others, like solar, wind, and biomass, are renewable, meaning they can be naturally replaced. It's important to conserve resources by recycling metals and plastics and by using sustainable materials that are better for the environment. We then have rates of reaction. The rate of a reaction means how fast a chemical reaction happens. Several things can affect this. When the temperature is higher, particles move faster, so there are more successful collisions. A higher concentration of reactants means there are more particles in the same space, increasing the frequency of collisions. If the reactant is in solid form, breaking it into smaller pieces increases the surface area, which also speeds things up. Catalysts are substances that speed up reactions without being used up themselves. Purity and chromatography is another important topic. A pure substance is made of just one type of material, like pure water or pure gold. If something has impurities, its melting point is lower and its boiling point is higher. Paper chromatography is a method used to separate and identify different colours in a mixture, commonly used with food colouring or inks. When learning about crude oil, remember that it's a mixture of many different hydrocarbons. These can be separated by a process called fractional distillation. Crude oil is heated so it turns into vapour and then it rises through a column where different hydrocarbons condense at different levels depending on their boiling points. Small molecules have low boiling points and are more flammable. Large molecules have higher boiling points and tend to be thicker and stickier. We also have organic chemistry, where you should know about two types of hydrocarbons: alkanes, which contain only single bonds, and alkenes, which contain at least one carbon carbon double bond. Cracking is a process where large hydrocarbon molecules are broken down into smaller, more useful ones, such as those used for fuels and plastics. Now, our next topic is life cycle assessments, or LCAs, which are used to compare the environmental impact of different products. There are four main stages: extracting raw materials like mining or cutting down trees, making the product, which may use energy and create waste, using the product, which might involve electricity or water, and finally disposing of it, such as recycling or sending it to landfill. Okay, then. Brush up on water treatment too, which is essential to make water safe to drink. It starts with filtration, which removes dirt and particles, followed by sterilisation, which kills bacteria using chlorine, ozone, or ultraviolet light. In places where fresh water is scarce, desalination is used to remove salt from seawater through distillation or reverse osmosis. You also need to understand the production of ethanol, which can be made in two ways. The first method is fermentation, where sugar is broken down by yeast to produce ethanol and carbon dioxide. This is a renewable process, but it's slow. The second method is hydration of ethene, where ethene reacts with steam to make ethanol. This method is faster but uses crude oil, which is a non renewable resource. Next, and we're nearly there, make sure to revise polymers. Polymers are long chain molecules made from smaller units called monomers. Addition polymers like polyethylene are made from alkenes. You'll also need to know how to test for ions. Flame tests are used to identify metal ions by the colour of the flame. For example, lithium produces a red flame, sodium gives yellow, potassium gives lilac, calcium gives orange red, and copper gives green. For negative ions, you can test for carbonates by adding acid. If carbon dioxide is produced, it will bubble. Sulfates are tested using barium chloride and hydrochloric acid, which produces a white precipitate. Halide ions react with silver nitrate and nitric acid to give coloured precipitates: white for chloride, cream for bromide, and yellow for iodide. Finally, we come to fertilisers. Plants need nutrients to grow, especially nitrogen, phosphorus, and potassium. These nutrients are provided by fertilisers. Fertilisers can be made by reacting ammonia with an acid to form a fertiliser salt. For example, ammonia reacting with nitric acid produces ammonium nitrate, a common fertiliser used in farming. Okay, those are our foundation separate topics. Last but not least, we have foundation combined. So these are the 2025 predicted topics for foundation combined science paper 2. The explanations are simplified to help you revise more easily, but it's still essential to review the full course content to be properly prepared for the exam. Now, let's begin with the Earth's atmosphere. Today, the air around us is made up of approximately 78% nitrogen, 21% oxygen, and 1% other gases, including carbon dioxide, water vapour, and noble gases. However, the atmosphere has not always looked like this. In the early stages of Earth's history, volcanoes released gases that filled the atmosphere with carbon dioxide. Over time, oceans formed and began to absorb some of this carbon dioxide. Eventually, plants and algae developed and started to carry out photosynthesis, which released oxygen into the air. This gradual change led to the atmosphere we have today. The greenhouse effect is important here because you should know how it links to climate change. Greenhouse gases include carbon dioxide, methane, and water vapour. Human activities like burning fossil fuels increase the amount of carbon dioxide in the atmosphere. Another important area to understand is combustion and the pollutants that come from it. Combustion means burning fuels. In complete combustion, a fuel reacts fully with oxygen to produce carbon dioxide and water. This reaction is efficient and produces more energy. In incomplete combustion, there is not enough oxygen, so harmful products like carbon monoxide and soot are also made. Carbon dioxide contributes to global warming. Carbon monoxide is a poisonous gas that stops oxygen from being transported in the blood, and sulfur dioxide and nitrogen oxides can cause acid rain. Particulates can cause breathing problems and pollute the air. Now, next, brush up on the topic of Earth's natural resources. These include materials we get from the Earth, like coal, oil, and metals. Some of these are finite, meaning they will eventually run out, while others, like sunlight, wind, and trees, are renewable and can be replaced naturally. It's important to use resources carefully. Recycling metals and plastics help reduce waste, and choosing alternative materials can help protect the environment for future generations. Understanding the rate of reaction is also important. A chemical reaction's speed is influenced by several factors. Higher temperatures make particles move faster, causing more collisions and speeding up the reaction. A higher concentration of reactants means more particles are present, leading to more collisions. Breaking solids into smaller pieces increases surface area and makes reactions faster. Catalysts can also be used to speed up reactions. They do this by lowering the activation energy needed for the reaction to happen and are not used up in the process. Next, revise purity and chromatography. A pure substance contains only one type of material, for example, pure water or pure gold. Impurities affect how substances melt and boil. They tend to lower the melting point and raise the boiling point. Paper chromatography is a technique used to separate coloured substances in a mixture, such as inks or dyes. It helps identify the different components present. You should also be confident with the topic of crude oil and fractional distillation. Crude oil is a mixture of hydrocarbons and it can be separated into different parts using fractional distillation. This process involves heating the oil until it turns into vapour. The vapours rise up a column and condense at different temperatures, separating them into fractions. Small hydrocarbon molecules have low boiling points and are more flammable, while large molecules have high boiling points and are thicker and stickier. Now then, in organic chemistry, you also need to know the difference between alkanes and alkenes. Alkanes only contain one single bond, while alkenes contain at least one carbon-carbon double bond. Cracking is a process where large hydrocarbon molecules are broken down into smaller, more useful ones, often producing both alkanes and alkenes in the process. Now, next, brush up on life cycle assessments, or LCAs, which are used to evaluate the environmental impact of a product. Throughout its entire life, there are 4 stages. The first is extracting the raw materials, such as mining or logging. The second is the production stage, where energy is used and waste is created. The third stage involves using the product. Some items may need electricity or water to work as well. Now, finally, the fourth stage looks at what happens when the product is no longer needed. Recycling is usually a better option than sending waste to landfill. Finally, the topic of water treatment is worth looking into as well. To make water safe to drink, it goes through 2 main processes. First, it's filtered to remove dirt and solid particles. Then it's sterilised to kill harmful bacteria. This can be done using chlorine, ozone, or ultraviolet light. In some places where fresh water is limited, desalination is used. This means removing salt from seawater using either distillation or a process called reverse osmosis. Okay, those are our AQA GCSE Chemistry Paper 2 predictions for 2025. If you need any extra support, our masterclasses are available as a pay monthly option where we offer live weekly revision sessions, exam workshops, and night before exam prep for a last minute confidence boost. We know it's getting intense at this time of year, but we really hope our materials can help at least ease the burden. Best of luck in your 2025 exams.